So the logistic regression model. So the model goes like this: y equals c over 1 plus a e to the negative bx. And if you remember this model, it starts out quickly in the graph, and then at some point it kind of starts leveling off. And that's the limiting factor there at c. So c over 1 plus a, that's the initial value. So it's going to start somewhere. And then c is the limiting value. Okay. So that's what a logistic regression curve looks like. It says the mobile telephone service has increased rapidly in America since the mid-1990s. Today, almost all residents have cellular service. The table shows the percentage of Americans with cellular service between the years 1995 and 2012. Well, what I'm going to do, I have this little grid so we could get a little bit better graph here. There's so many points. But I want my x-axis to be here and my y-axis to be here like that. And this is going to represent the year. And we're going to make 1995 year 0. Okay? So I think I'll just count 1, 2, 3, 1, 2, 3, 4, 5, year 5, year 10, year 15, and year 20. And we're going to count our years. 1995 will be 0, 1996 will be 1, 2, and then so on. Let's see. And then it looks like on our percentages, we start out at 12, but the last one in 2012 is like 98%, so pretty high. So I'm going to count by fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, and then 85, 90, 95, 100 up here at the top. Okay, so we're not going to have more than 100%. All right, to graph this so I don't have to like keep scrolling it up and down, I printed out the numbers of the chart, so hopefully I can read this teeny tiny print. Okay, so in 1995, year 0, it was 12, and we're counting by fives, right? So there's 10. So it's going to be like right there. Maybe I should put a black dot there. So it's like right there. And then in year 1, it's 16. It's a little bit higher there. And then in year, let's see, that was 1. 2, it's just over 20. Year 3, 25. And year 4 is like 31. So it's going up pretty good here. The next year, year 5, is going to be 39, so almost to 40. I don't know why it does that. It's just this program. And then year 6 would be 45. Increasing, still pretty good. Year 7 is 49. Okay, now maybe it's starting to taper off. In 2003, so year 8, so 8, yeah, 55. It's going to be like there. And year 9, let me make sure I'm okay. Yeah, 9, it looks like it's 63 about. So year 9 is going to be over 60. And year 10, what does that say? 69 about. So let's look up here. And year 11, 77 almost. And next year is like 82.4. And the next year is 85. And then 89. And then 92, almost 92. Just kind of drawing little lines there. And then 95. Let's see. Kind of had a jump there. And then 98. So it's going up pretty quickly, and then it's kind of starting to level off there. Okay, so that is a logistic model then, by the shape of the curve, all the data points. Okay, let x represent time in years. We did that. We said x equals 0 for the year 1995. Let y represent the corresponding percentage of residents. And then we made the graph, and so it fits that model. Okay, so here's the actual numbers now. Use the model to calculate the percentage of Americans with cell service in the year 2013. Well, I'm going to have to figure out what that is then. So, whoops. If this was 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And so the next year would be 2013. So x is going to equal 18. Okay, so we've got our x value. Why isn't it scrolling? Why isn't this scrolling? Sorry about that, technical difficulties. I think it's scrolling now. It stopped. Okay, there it goes. Now it's moving. Okay, so x is 18. We have then this model, so we're going to put in 18 for x. Now, one thing on this one, you want to make sure you put in this number, then you're going to put in the division, and then you need to open a parenthesis, 1 plus, and then you're going to put in all that other stuff. So after the E, it should give you another parenthesis, so you can put in that long number, and then times 18. So that's, I didn't put the long numbers in, but you're going to put in that long number first on the numerator, and then divided by. Anyway, you do all that, and in my calculator I got approximately 99.34075. So if I'm rounding that off, it's about to the nearest 10, it's 99.3%. So that's a pretty high percent for people to have cellular service. That's what you know. Okay, now part C, it's just kind of a little bit of a talk here. It says the model gives a limiting value of about 105. That's this number right here. It says this means that the maximum possible percentage of Americans with cellular service would be 105%, which is impossible. You can't have more than 100% of the population, right? Okay, so it says how could over 100% of the population have cellular service? If the model were exact, the limiting value would be C equals 100, and the model's outputs would get very close to, but never actually reach 100%. After all, there will always be someone out there without cellular service. So I think they were making a little joke in the book, but they're just talking about what those numbers mean.